Hello everyone, it's Wilson here. Today I want to talk about a lot of examples in factoring trinomials. So let's get started. So if you look at this one here, the A is 3, so that's not 1, so that usually makes it harder. But instead of using the AC method here, I'm going to use the trial and error method here. So if you have seen my animation video for the general idea for the trial and error, then you know the setup already. If you haven't seen it, you can actually still just learn about the setup here, but I would suggest you just go watch that video first, right? Okay, so let's get started. So first, we are going to write down the two terms that will multiply to this term 3x squared right here. So one easy one that we put is just 1x and then 3x. Then you may say, is that the only combination? Yes, because the order does not matter here. Either you can put 3x and then 1x, or you can put 1x and 3x here. Okay, so it doesn't matter. And so because 3 is a prime, and when we factor over the set of integers, then this is the only combination that we can have for the prime number. Okay, and so now the 4 you actually have like two choices, because if you just look at the 4 here, the 4 have 1 and 4, and then you can also have 2 and 2. And then you may say, which ones should we use then? We just gotta try, right? Because this is called trial and error. So we can try 1 and 4, and then let's see what happens. So we can try 1 and 4 here, and then we can just do this. And then now what we do is that we are going to just multiply following the line right here. So we are going to get 4x for this one, and then the 3x times 1, we are going to get 3x. Now, if you add them, you're going to get 7x. If you subtract them, you're going to get 1x, right? Ignoring the signs for now. You're not going to get the 4. So we know that this combination does not work. Is that okay? So that's how you realize that, okay, so it doesn't work, then we just got to try another one. How long does it take? Doesn't even take long. So don't be afraid of trying. And then we know that if we switch the 1 and the 4, don't switch the first column here, just switch the 1 and the 4. And you know that you're not going to get the 4, because the 4 times the 3 gives you 12, and then the 1 multiply with the 1. It's not going to give you that. I'm not going to show the that try here. I'm just going to just use the other combination, right? So 1x, 3x, and then we have 2 and 2, and let's see what happens. So we put the 2 and the 2 here, and then what happened is that the 1x times 2 gives us the 2x, okay? And then the 3x times 2 gives us the 6x. Then now if we take the difference, we are going to get the 4 here. Now the question is, how can we take the difference? That means we need one of them to be to have a positive sign, and the other one to have a negative sign, so that we are subtracting those two numbers. So now we getting the 6 and the 2. How do we get negative 4? The negative sign should go with the larger number here, because if you have a negative sign going with the 2, then you're going to get positive 4. But we want negative 4 right here. Okay, so what should we do? We are going to simply just put minus here. But now in order for you to get minus 6x, we have to do 3x times the negative 2x, right? So we also need to put a minus sign here. Yeah, so what happened is that once you have determined what sign that you're going to put here, you also need to put it in this column. Okay, so I put the minus sign here, then I'm going to put the minus sign here. Now, just do a quick check. We know that this is giving us the negative 4x. And then, but that's not finished. We also need to just multiply those two to see if we are getting the last term, the constant term. So negative 2 times 2 gives us negative 4. So the signs, all the signs will work now. So right now, this is the correct try. And so this is the correct factorization. And then you may say, how do we write down the answer? The answer is actually really simple to write down. So what happened, okay, is that you just read across. Okay, so 1x and then minus 2. So that's our factor. Okay, so x minus 2. 1x is really just the same thing as x, right? X minus 2. What about this one? This one is 3x and then 2. There is no negative sign here. We assume is positive. So we are going to get the factor as 3x plus 2. And that's basically our factorization. That's our answer. Is that okay? That's simple, right? Let's look at another example. Okay, so we have this one, 2x squared minus 9x plus 10. Okay, just like the previous example, we are going to start by just writing 1x and then 2x. Okay, so see that that's simple because 2 is a prime number, so that makes the combination easy because 1x times 2x gives us 2x squared. Okay, now, what about the 10? The 10 right here, we have what? For the 10, we can have 1 and 10, and then 2 and 5. And so I usually call this 1 and 10 the extreme case. So what that means is that it's going to produce the middle term. If you choose this kind of combination, it may produce a term that's really either quite small or large. It's far away from those two numbers. So in this case, I usually try not to use the extreme case at the beginning. I usually would try to deal with the other cases, right? So like 2 and 5. Now, regarding putting the 2 and 5, it's not a good idea to do it like this. The reason is really because if this is the answer, then we have the factor as 2x plus 2 or minus 2, right? But see that there is a 2 that you can factor out. The problem is that we cannot factor out a 2 from the original expression. I explained this in my animation video for the trial and error method. Just briefly explaining here, this is not going to be the combination. So we can rule this out really quickly, okay? So it would actually be a good idea to just try put the 2 here and then put the 5 here. And then let's see what happens. Okay, so now do the multiplication. We have 1x times 5, we get 5x, okay? And then we have 2x times 2, we get the 4x. Okay, so see that in order for us to get a 9, we actually need to add them together. Okay, so that's simple. Now, to add them together and to get a negative 9, we need them to have the same sign. So if they have opposite signs, then you're subtracting the two numbers. So you need to have the same sign. So that means we want negative 4x and negative 5x. And remember that I mentioned in the previous example that we, if there was a minus sign here, then we also got to put a minus sign here, and then also put a minus sign right here. It's really because you have to have a negative number here, so negative 5 times 1x will give us negative 5. Is that okay? Same thing here with the 2x times negative 2, it will give us negative 4x. Okay, so we have this. And then so adding them together, we get negative 9x. What about the 10? Positive 10, negative 2 times negative 5, because they are both negative. So when you multiply them together, you get positive 10. So this is the right combination. Everything works. So right now, we would just write down the answer. Okay. So we write down the answer. How do we write down the answer? Again, just read across. So x minus 2. Okay. So don't follow the line when you're writing down the answer. Just read horizontally, right? So 2x minus 5. So that's the second factor. Okay, so we got the answer for this one. Let's try another one. Let's try a more difficult one this time because the two previous ones were more like warm-up, right? This time we have a large a value here. This a is 16, right? So if you use the AC method, this is going to be bad because 16 times 6 gives you a big number with a lot of combinations. Okay, so now the 16, what happens? Regarding the 16, it would be a good idea to just look at all the combinations right here. So 1 and 16, 2 and 8, and then 4 and 4. That's all the combinations here. And then regarding the negative 6, actually, I'm just going to look at the 6, right? Ignoring the signs at the beginning. So we have 1 and 6, and then 2 and 3. Now, it's actually possible to go to all the combinations, right? But it's unnecessary, as I said. Sometimes you can just rule out the choices really easily. For example, so if I just choose 2 and 8 at the beginning, okay? So 2x and 8x at the beginning, okay? So now when we try to put down 1 and 6, let's say we put the 1 and 6 like this or the other way, right? Do you see the problem here? If you just look at this factor here, if this is the answer, then there is a GCF of 2 that you can factor out. But we cannot factor out a 2 from all 3 terms at the beginning. So you know that this cannot be the right combination. Even if you switch the 6, because they're both even numbers, the 6 is either paired with the 8 or the 6 is paired with the 2. So that's a problem. So you may say, what about the 2 and the 3? And then if you put the 2 and the 3, do you see the problem here is that if you just put the 2 here, there is a GCF. If you put the 2 down here, also a GCF. So we know that doesn't matter what you use for this one, okay, it's never going to work so well, right? Not going to work, actually never works, right? So don't even bother trying any of the combinations right here, so we can rule out that one. Now, same thing for the 4 and the 4, because they're both even numbers when you put it in the first column. So no matter how you put the 1 and the 6 or the 2 and the 3, there is a GCF in your answer. But then there was not a GCF of 2 from the original expression, so that's not possible. So the only choice that we have left is actually the 1 and the 16. Is that okay? So we are just going to put 1x and then 16x. Okay, so now we got in putting the 1 and 6 and the 2 and the 3. And again, I usually try not to use the 1 and the 6 because I call that the extreme case, right? So we can try to do the 2 and the 3. We know not to put a 2 here because that will cause us to have a GCF. So I'm just going to put the 3 here, and then I'm going to put the 2 here. And then we'll just try it. So what do we have here? 1x and 3, so we get 3x, and then 16x, and then 2. So what do we get here? 32x. Okay, can we get the 29x? Yes, right? So so 29, how do we get the 29? We want a minus, so the sign should go with a larger number. Okay, so minus right here and then minus right here. See that it's simple. So -2 times 3 gives us -6, so everything works. Now that's the final answer. So based on the answer right here, so let's put down the answer. So we have what? 1x minus 2, so x minus 2. And then what about this one? 16x plus 3, so 16x plus 3. Finish, right? So easy, right? So that's why I said using the trial and error method would actually be a lot simpler, because there are fewer steps compared to the AC method. I'm not saying the AC method is bad, but it's only easy when the problem is simple, when the A is not too big, okay? But when A is big and the C is big, when you multiply them together, that's big, and that's too many combinations. And so by doing it this way, we can see easily that we can rule out a lot of combinations. Okay, so let's continue with the next one. Here is another one. Again, I pick a problem that has a large A and a large C. So when you multiply them together, terrible. Okay, so write down the combinations right here. So the A has the 24. So let's see what happens. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Is that okay? So what about the next one? The next one is the 15, and then 1, 15, and then 3 and 5, right? So again, way too many combinations right here. So I will tell you that we can roll the 3 and the 8. It's really because you can see that it's hard to get a 2 in this case, right? But I'm still I need to try to actually show why we can rule that out. So you may say that, okay, so we just gotta try. Now, the 3 and the 8, because A is a big number, so when you try to multiply with the 15, that's going to way too big. So there's no way that you can get a 2, right? So even if you still want to try the 1 and the 15, we probably have to do like the 15 right here and the 1 here. But here comes the problem. The 15 is too big, so when it's being multiplied with the 3, you're going to get 45. And the 8, can you get a 2? You know that it's not going to work, right? So you just say no, right? And then you just switch, because right now, if we do not really have a specific choice, we just got to try. This is big, right? This is big. And then this is 3. Okay, so sometimes you don't even need to bother with figuring out the calculation, because you know that there is no way that you can get a 2, because in order for you to get a 2, you have to have like a 5 or 1 here, but that's not the case here. So we know that that's no, right? So we cross them out. And then you may say, what about the 3 and the 5? We should still just try it. right? Okay, so 3 and the 5, well, the 3 cannot be put here as you can see in the previous examples, right? So you can only try the 5 and then the 3 here. Now this is 40x, this is 9x. Well, no way that you can get a 2, right? So cross that out. And then I don't even bother with the 3 and 8 anymore because I have tried all the combinations, right? So what about the 4 and the 6? And again, I try to avoid using the more extreme cases right here. So let me try the 4 and the 6. Okay, so we're getting the 4x and the 6x. Let me think a little bit. So if I want to avoid the extreme case, I probably should really try 3 and 5 first, right? And so if I try 3 and 5, I know that I cannot put a 3 here with a 6. Again, the same reason with the GCF stuff, right? So we got to try the 5 here and then the 3 here. So what do we have here? 20x, and then the other one is what, 18? Okay, sounds like good news because if we had 20x and 18x, we are going to get a 2. So how do we get a 2? A positive 2. We need the minus sign to go with a smaller number, which is the 18 in this case. So what do we have here? Minus 18 minus 3. That okay? Just do a quick check. Negative 3 times 5 gives us negative 15. So everything works. Final answer, which is what? 4x minus 3. Right? Just read across 4x minus 3 and then 6x plus 5, right? So 6x plus 5. Finish. Easy one, right? Okay, so let's look at one that has a GCF at the beginning, right? So you can see that all 3 numbers are even. So that means we can at least factor out 2. Actually, we can only factor out 2 from here. So what we want to do at the beginning is to just factor out the 2 as a GCF. Sometimes the trial and error will still work when there is a constant GCF, but I will say that it's always a good idea to just check if there is a greatest common factor that you can factor out. If there is, factor out first before you go to the trial and error method. Okay, so we factor the 2, then we are going to get x squared minus x plus, oh, actually there is a 2x squared, right? So 2x squared minus x, and then plus the 3. So now we have a regular looking trinomial, right? That we usually can try to use trial and error. So you look at the 2 right here, then we are going to get 1x and then 2x right here. Okay, now you may say, where do we put the 3? We know that we shouldn't be putting the 3 here because we put the 3 here, 3 times 2 gives us 6, and then there was no way to get the 1, right? So it would only be possible if we put the 1 and the 3 like this. So that when we multiply, right? So 1x times 3, we get 3x. And then 2x times 1, we get 2x. Okay, so sounds like good news. We can figure the 1. We want a negative 1 here, so that means the minus sign should go with the larger number, the 3. Okay, so we have the minus here, minus here. Now, we cannot just write down the answer from here because we gotta still check this column and see if those 2 numbers will multiply to the constant term. So now 1 times negative 3 here, what happens? We get negative 3, but that's positive 3 here. So what does that mean? That means this combination, it looks like it's working because the middle term works, but it actually does not work. Is that okay? So we cannot just blindly apply this whatever method that you call it, right? We cannot just blindly apply this because we have to just make sure all the signs will be correct. In this case, it doesn't work. Okay, so this doesn't work, and then we have no other combinations that we can try. So this is actually not factorable over the integers. So that means that's our answer. We still factor this expression, but it's only a GCF. I picked this example here because I just don't want you to just blindly use the trial and error method and only check the middle term. We always have to check the last term as well with the signs. Is that okay? It's easy to fall into this trap, but now it should be better, right? Once you have seen this example here. Yeah, so let's go back to normal. Let's do something that we can factor. So next one. This one is not a quadratic expression because you can see that there was a fourth power here. So this is an expression in the quadratic form. Is that okay? So how do you say that that's in the quadratic form? Because this thing right here, let me use a different color. Okay, so this thing right here actually looks like what? 8 and then something squared minus 6 times something and then minus 27. What is that something? What is that stuff in there? It's x squared and then x squared. You see what's going on here? X squared gives you x to the fourth. So this is still, this looks like a quadratic expression, right? So even though it's not a quadratic expression, so we can still use trial and error to factor this. How do you do it? The idea is simple. You just need to make a little bit of the adjustment, right, for the first column because of the x to the fourth right here. So for the 8, we can try 2x squared and then 4x squared. Okay, then you may say, why do we put x squared here? Because x squared times x squared gives us x to the fourth. This is the adjustment that we're going to make. Okay, now for the 27, let's try the non-extreme case here. Let's try 3 and 9, or 3 and 9. Okay, so I'm just going to put 3 and 9 right here and see what happens. Sometimes when you get lucky, you figure out the answer really easily, right? Maybe just first try, you figure out the answer, then you're finished. So 3 times 4x squared, we get what? 12x squared. And then 2 times 9, we get what? 18 with the x squared, right? So 18x squared. Can we get the negative 6x squared? There was the x squared right here, so we do have the x squared. Yes, we can, right? We can get the negative 6. How do we get the negative 6? We want the minus sign to go with the 18 because we want a negative number here, right? So minus sign going with the larger number, the 18, so we put the minus sign here and the minus sign here. Okay, and then again, just based on the last example, always check this column right here to see if we can get the constant term. 3 times negative 9, negative 27. Good, finish, right? So we can write down the answer. So what do we get here? We get 2x squared plus 3. Okay, just reading across, right? And then 4x squared minus 9. So we have 4x squared minus 9. So we factor that. Now, this problem is not finished because for this kind of expression right here, you're still going to get a quadratic expression, which may be factored further, right? So in this case, you can see that this is actually the difference of 2 squares. So we can factor this, okay, as 2x squared plus 3. Okay, continue to factor this 2x squared, 4x squared minus 9. Yeah, so that factors into 2x plus 3 and then 2x minus 3. That's really due to the difference of 2 squares formula that we have. So a squared minus b squared is equal to a plus b. Okay, a minus b. I will do more videos on factoring the difference of 2 squares here. So for now, my main focus is on the trial and error, so I'm not going to spend too much time to explain this. You can look that up for now, or you can also wait for my future videos for talking about how to factor the difference of 2 squares. Okay, so this problem is finished, and then let's look at the next 2. Okay, so why do I put them this way? It's really because I just want to show you that when there are multiple variables, we can also use the trial and error here. Is that okay? So, but the form must be correct. So one form should look like this: x squared, and then there was a y squared in the last term. The middle term should have a first power for the x and also the first power for the y. That's one form that you can factor it, like how you usually do with the quadratic trinomial. Another one is when you have you have the form like this. So there is no, the last term is still a constant term, but you have an extra variable here with the y-score, and then there was the linear factor of the y right here. But then this is not linear, of course. This is x times y, right? Okay. So now the coefficients are the same. So we only need to do it once, actually. So let's just focus on this one for now. 14. You can use 1 and 14 and 2 and 7, but I usually would go with the non-extreme case, right? So we are just going to do 2 and then what is that? The 7, right? So 2x and then 7x. Okay, now what about this one here? The 20. 20, let's try 4 and 5, right? 4 and 5. Well, we know that we cannot put the 4 here because the 2 and the 4, there's a GCF, right? So switch them. See that sometimes, even without trying, when you put it down, you already know that something's wrong. So don't even bother moving forward, right? So 2x times 4, we get 8x. And then 7 times 5, we get 35x. Okay, do you see what's going on here? 35x and 8x. You add them together, you get 43. And there is no minus sign that we need to put anywhere because all the signs are positive in this example. Okay, I actually picked this example on purpose because all I want is to demonstrate how to deal with the extra variable. My main focus is not on dealing with the combination of the trial and error, so that's why I just picked the combination, the correct combination right away. Okay, so we have 35x and then 8x. Is that okay? So the answer for this one, actually, there was one thing that I was missing here. Do you see what I missed? 5 times 4 is 20. It doesn't give us y square, right? So here's the problem. So you may say, how do we make that adjustment? Well, do you see what's going on here? If I put the y here and I put the y here, do you see what's going on here? When we do 2x times 4y, we are going to get 8x, and then with a y, right? So axy. And then 7x times 5y, we get 35xy. Do you see that when you add the 35xy and the 8xy, we get 43xy here? That's why we need the expression to be in this form, because once you put the y right here, when you multiply them, then you're going to get the xy. And that's why we have to have xy in the middle term. If we have an x in the middle term, this method does not work, right? It may not be factorable. So in this case, we can write down the answer, which is what? Just 2x plus 5y, okay, right? First row, and then second row is 7x plus 4y. And then we're finished. Now you may say, what about this one? It's the same combination because the 3 coefficients are the same, right? So same combination. But the difference is that because there is a y square here, in order for us to get the y square, instead of putting the y in the 5 and the 4, we got to put the y right here. So we got to put y here and then y here to make that adjustment. Is that okay? So 2xy times 4 still gives us the 8xy. And then 7xy times 5 will give us the 35xy. Do you see that we still get the same middle term, right? But the difference is that the y now goes with the first terms for the 2 factors. Is that okay? So now how do we write down the answer? The answer for this one would be 2xy plus 5 and then 7xy plus 4. See how they're different? I put those 2 examples side by side just for you to compare how to make those adjustments. Yes, the form must be right so that you can use a trial and error. The trial and error cannot be used to factor anything that's not in the right form because it doesn't work, as you can see. If we just omit the y, let's say there was no xy here, there was just a y here, then there was no way that you can only get a y and then there was an x squared right here, or x squared, y squared right here. Okay, so we are going to go to the last example, and we are just going to end the video with a more difficult example right here. Look at this one with more than one variable, okay? And then also it doesn't even seem like it's in the right form. But as I said, the first thing that we always need to do when it comes to factoring is to check for the GCF, the greatest common factor. Now, if we look at the 6, the 111, and then the 54, you can see that 3 goes into all of them. And so that means 3 is a common factor to all those 3 numbers. But 3 is not the greatest common factor. It's really because you can also factor out the variables. So first thing, we factor out the 3. Okay, now let's check the variables. X cubed, x squared, x. So we can factor out the x because that's the lowest power among all 3 terms. What about the y? Y cubed, and then y cubed. So for all 3 terms, we have a y cube, so that means we can factor out the y cube. And so now, once we factor that out, we can just write down the stuff that's left. Factor out the 3 from the 6, we are left with the 2. And then we pull out the x from x cubed, so we get the x squared. Okay, minus, the signs won't change. What do we have here? 111 divided by 3, we are going to get 37. Okay, 37. X, it's really because we pull the x out from the x squared. The y cube got factored out completely, so there is no more y in this expression here. But then the x squared, factor out the x, we get x. And then plus 54 divided by 3, right? We factor out the 3 from the 54, so we are going to get 18. And then xy cubed got completely factored out, so 18 becomes the constant term. So now we use trial and error on this thing right here. Is that okay? So we got to use the trial and error on just this expression right here. Okay, so the 2 is easy. So 1 and 2, 1x and 2x. Now we're getting the 18. Usually, as I mentioned, we should try the non-extreme case right here. There is one thing that's in the problem that will tell us that we should try the more extreme case. What is that? The 37. See that the 37 is significantly larger than the 2, and then it's somewhat far away from the 18. So if you have like a 21 here, then I will probably just try the 2 and the 9. But because this number is also quite far away from the 18, okay, then we should try the extreme case and see what happens. So instead of trying 2 and 9, I'm going to try 18 and 1. Okay, it's because we need a number large enough to get the 37, right? So 2 and 18, we get what? 36x, okay? And then 1x and 1, we get 1x. That's how we can get the 37. See that if you try it, let me just show you. If we try 2 and 9, we know that we gotta put the 2 here with the 9 here. We cannot put the 2 at the bottom, right? So we multiply them together. You are going to just get 4x and then 9x. See that there is no way that you can get a number as large as 37. So you know that combination does not even work. So that's why I would decide to try the more extreme case in this case. Okay, so now negative 37, we want them both to be minus. Is that okay? So both to be minus. Yeah. And then also check this column. Negative 18 times negative 1 gives us positive 18, so that works. Okay, so that's our factorization. So our answer, our final answer would be what? Would be x minus 18 and then 2x minus 1. Okay, yeah, so but that's not the final answer. Why? Because we still have a GCF in the front. So just one thing to keep in mind is that once you're done with the trial and error, when you put down the factorization from the trial and error, make sure that you also include the GCF as part of your final answer. Is that okay? It's easy to forget, right? It's easy to forget. So just make sure that you include that. And then now that would be our final answer. Is that okay? It's not that bad, right? So I will do more videos on other types of polynomials factoring. So please stay tuned for that. To help make math learning available to everyone, please share my videos to others and subscribe to my channel. It will give me support to make more videos. I want to work together with you to help students and children learn math more easily.